Welcome to another episode of Natural Gas World's In a Nutshell podcast. I'm Joseph Murphy, and today I'm joined by Jean-Francois Gauthier, Vice President of Measurement and Strategic Initiative at global satellite emissions monitoring company GHGSat. And we will be discussing a recent pilot project that GHGSat has been involved in alongside OGCI and Carbon Limit, based on a study to quantify methane emissions at oil fields in Iraq. Jean-Francois, a good place to start, really, for the benefit of the audience is, can you outline what your company is doing and your journey so far?
Right. So first of all, thanks for having me here, Joseph. It's great to speak to you today. So GHGSat measures greenhouse gas emissions, especially methane, with its own satellites. And what really separates us is that we do this directly from industrial facilities around the world. So of course, focusing on methane, oil and gas is our primary market. So aside from our satellites, we also do this with our own aircraft sensor. It's the same sensor that we find on the satellites. And then in addition to that, we also ingest public data from other satellites on a daily basis, and we process that information and use it to augment what we do with our own data.
Mm-hmm. And could you tell me a bit about the resolution of your satellites? So, when you're looking for methane emissions points, how small can they be detected?
So when we speak of resolution, so there's detection threshold and there's also spatial resolution, so the size of the pixel. So and the combination that we offer is very unique right now in the world. So we offer a 25-meter resolution in terms of spatial resolution, in terms of pixel size, which means that we are able to very clearly attribute emissions to a specific site. So when we detect emissions, there's no doubt, there's no challenge or guesswork as to where it is coming from. We know exactly which facility it is coming from. Now, when we talk about the other side of that equation, the detection threshold, we detect any emissions that are above 100 kilograms per hour. So that's still a very large emission, but when it comes to satellites, that's actually quite small, especially to do routinely, and not only to do it routinely, but to do it in any sort of setting around the world. So we can have the same sensitivity like this in, for example, in the desert of Algeria as we do somewhere in the US or Canada, for example.
Mm-hmm. And can you outline what the main purpose of this report was, and what was your role in the study, and what were the roles of OGCI and Carbon Limit?
Yeah, so we decided to write a white paper on this because it was such a unique project, and to our knowledge, it was a bit of a groundbreaking attempt at bringing together a monitoring technology like ours. So that was our role in the project. It was to look, identify sources of emissions, and more importantly, identify opportunities for reductions. And also this project was bringing together a group like OGCI here that brings not only expertise in oil and gas by virtue of its members. The companies that are members of OGCI are well known, but also they bring the industry angle to this, and the ability, when contacting operators on the ground, to reassure that this is a joint project. We're all working together to reduce emissions, and this was obviously very well received, as you saw in the report and the results of that. And the third leg of that stool, so to speak, of the third member of that project is a company called Carbon Limits, and Carbon Limits brings a very unique expertise to educate the operators on the ground, work closely with them to not only give them strategies to reduce emissions, to actually fix the leaks or address the emissions that are happening, but also to provide them with longer term strategies, for example, for preventative maintenance and best practices in order for leaks to occur at a less frequent rate in the future.
Hmm. And what would he summarize the main findings of the report? What did you learn?
Well, we learned a lot actually, and the most important thing that we learned is that engaging with operators on the ground or in different countries in the world is possible if it's done the right way. So it is very easy for operators to feel maybe not threatened, but a little bit taken aback and a little bit on their back heel to when they hear about their emissions. So there is certainly a dialogue that needs to take place, and the way we went about doing this proved to be very successful. So that was a very interesting learning, because it sets the blueprint to do this in other countries, because now it's a model that was designed to be very scalable, and that's precisely what we're doing with this. So as you saw in the report, we're now taking this to other countries like Algeria, Kazakhstan, and Egypt. And the potential to roll this same methodology to other countries is an absolute possibility now, as we continue to learn through the experience in these other countries as well. So the other thing that we've learned is that it is possible to very precisely identify emissions from different sources as well. So you saw in the report that there were different pieces of equipment that were responsible for this, from unlit flares to other pieces of equipment that were leaking, and not all are born equal in terms of how easily the repairs can be performed. So it's very important when looking at these types of programs to really start with the lower hanging fruits. For example, an unlit flare, as I mentioned a second ago, which are typically, comparatively speaking anyway, easier to repair and usually have a big impact, because they tend to vent a lot of methane straight to atmosphere if they are malfunctioning. So and then, once these are addressed, then it's possible to move to the other aspects of the other pieces of equipment that may require more capital or more time to fix. So another thing that we've learned is that it is possible for operators to take interim measures to, for example, redirect the gas somewhere else in the facility in order to temporarily address the problem while the equipment was being fixed. So this type of this ability to be proactive cannot be underestimated. Once the knowledge is there of where emissions are and the magnitude of them, it is possible to make really well-informed decisions on how to proceed. So these are some examples of the learnings that we've had. A last one that I could mention is that we've certainly learned the power of frequent monitoring at sites like this. And when I say that, I mean that it is widely known now that methane emissions in oil and gas can be intermittent. They can come and go. It really depends on each site, on each emission, on each leak. And having frequent data, the ability to revisit frequently, really starts providing proper context, proper situational awareness to make those decisions I spoke of a second ago in terms of prioritizing action. So it is, the priority usually will go to sites that are or pieces of equipment that are emitting on a more persistent basis, as opposed to the ones that might be intermittent, because more investigation might be required to figure out the causes of the intermittent ones. But the persistent ones are the proverbial low-hanging fruits I spoke of earlier as well. So our satellites now, the constellation that we have, allows us to revisit sites frequently enough in order to start getting a full picture here on how to take action.
Hmm. I have a few follow-up questions, but just to zoom out for a bit, why was Iraq chosen as a location, and how did you identify the group of fields which you decided to study?
Yeah, so it was we used a bit of a methodical approach to do this. So we did an initial look with our satellites because there's so many different fields, so many oil and gas installations.
Hmm.
So we tried to select an area where engagement would be most likely, because of course this was
Hmm.
a bit of a pilot project, like, so we're really trying to reach have the best chance of success early on so we can learn from this, but also lay a foundation to continue expanding these types of projects. So one of the learnings I did not mention, because there's so many lessons learned, but an important one was that any with any operators where we had previous contact, engagement was much more rapid.
Hmm.
In some cases, when we did not have prior contact either through OGCI or carbon limits or ourselves, it took up to 10 outreaches to different individuals in order to finally reach the right person. So it was
Hmm.
possible, but it required a lot more sustained effort to get there. So in trying to select areas, we tried to also do a prior survey of the connections that we had in country, so that we can maximize that ability to engage as quickly as possible in order to drive results. So that summarizes the approach that we took to that.
But was there a reason specifically Iraq rather than another,
No, I mean,
major
there's
oil
no,
producer?
we've looked at several countries, and OGCI has involvement in the country, so
Hmm.
it helps that they have a presence there. Several of the members have a presence, and
Hmm.
they have relationships that are built. So again, in the name of facilitating engagement and trying to get the results as quickly as possible, even if the actual operators that we were contacting were not working directly with these companies. They're actually the fact that they're present in country helps
Hmm.
with the engagement. So that was one of the criterias. But again, it could have been some of the other countries that we're now turning our attention to as well.
Hmm.
We had to start somewhere, and Iraq presented a great opportunity to do that.
Okay, sure, sure. So going back to the types of equipment which were identified as the major sources of emissions, was there a particular type of equipment which was producing more emissions? Was that consistent at all of the oil fields? And also, what did you find out about if there if a type of equipment was causing emissions, um, which types of equipment were easier to, in terms of cost and other factors, to repair or replace and fix the problem?
Right. So I touched on that a little bit earlier. I can
Yeah,
certainly expand on that a little bit, but so flares are a big opportunity, not just in Iraq, but
sure.
many places, many countries that are operators of oil and gas fields around the world. So inefficient flares that might be malfunctioning and venting straight to atmosphere, like,
Hmm.
that's one of the easier pieces of equipment to fix. I mean, I certainly don't want to trivialize the work that's needed to repair and upgrade some of these devices. But
Hmm.
comparatively speaking, it's easier to address this usually than it is to troubleshoot a compressor station, for example. So that's certainly something that we've identified, and certainly one thing that we've noticed is that uh, the types of equipment that were leaking in Iraq were no different than what we see elsewhere in the world. So very
Hmm.
consistent. Flares, like I said, are a fairly common occurrence, and things like maintenance events as well, which are more on the intermittent side of things as opposed to persistent. But
Hmm.
maintenance events can cause large releases of methane. We often hear about them in the news now as being captured by one method or the other, and at that point it comes down to best practices to try to avoid releasing so much gas during the maintenance events. But if I had to list one particular piece of equipment there, that it would be the flares. That's certainly a big opportunity for sure.
Okay, and you were talking about the frequency of monitoring. How frequently were your satellites surveying a particular field?
So we were looking at 6 sites in countries.
Yeah.
So the goal was to look at them several times a month. So of
Okay.
course we are restricted by cloud coverage, but Iraq was also selected from the perspective that weather tends to be fairly
Sunny.
favorable, sunny, fairly favorable for satellite observations because cloud coverage tends to be maybe less frequent than in other parts of the world. So we need the sunlight to make our measurements because we measure the absorption of methane of sunlight by the gas, but by the gas of interest, in this case methane. So the fact that it's a more sunny area allowed us to make more repeated measurements there. So we were able to look at these sites in many cases 2, 3, 4 times a month, especially towards the latter end of the period that we reported on, because we had launched new satellites that allowed us to increase that cadence. So and the paper discusses the project about 9 months into it. We're obviously continuing that now, and the fact that we have more satellites now in orbit, and we're launching 3 more this spring, and another 3 at the end of the year. So this increase in capacity allows us to go from what we used to do like years ago, which was monthly monitoring at a site. Now we can do it multiple times a month, sometimes weekly. And now, by the end of this year, we'll be able to monitor daily at some sites. So that's often too much, but the possibility is there, especially if there's a need to characterize some sources more in greater depth in order to really figure out the scale of the problem, because it's not enough to just characterize are the emissions persistent or intermittent, but also it's great to be able to understand whether or not they're variable. Like, are they fairly constant? Are they jumping? Is the intensity, the magnitude jumping up and down as well? So the more data points you have, the more you can prioritize decisions and take corrective actions in a methodical and thoughtful way. So that's basically what that increase in measurements permits.
And can we put numbers on how much the operators were able to reduce their methane emissions by?
Yeah, so we offered some numbers on that. So the average rate of emission of the sites that we looked at was 1.5 tons per hour. So some of those sites were able to be addressed, and others were not, at least not immediately. But the ones that were fixed that's kind of the magnitude that we're talking about. We're talking about reducing persistent sources that are in the order of 1.5 tons per hour, which is quite significant. That's the equivalent of feeding energy to 43,000 typical homes in the U.S. So that's the scale that we're looking at, and that's still a very limited project. Like, admittedly, here, this is not meant to represent the situation all over Iraq, but it does highlight that there is an opportunity to expand these types of programs, and it provides an idea of the scale of the impact that can be achieved relatively easily, all things considered. And again, very important to not minimize the effort that's needed on the ground to repair some of these events and troubleshoot them properly, because having the initial measurement is only the beginning. There's a lot of work that needs to be done on the ground to pinpoint exactly where it is coming from, and devise a plan in order to fix them.
Mm-hmm. I mean, judging by those reductions, it's obviously an effective. Your satellites are obviously an effective tool to identify, the big emitters. But I mean, you've mentioned some already, but can you take me through what other limitations satellite monitoring has? Obviously, a standard operator won't just use satellite monitoring. They'll also need, the ground level stuff with cameras and etc.
That's correct. And at GHGSat, we really believe that satellites are a really crucial, really important part of that puzzle, of that solution, because satellites can identify the biggest sources rapidly and then qualify them in a way that allows you to make those decisions I spoke of a second ago. So by addressing those big leaks as quickly as possible, you handle a big part of the problem very quickly. So, there are studies in the U.S. that look at the distribution of emissions, and for example, super emitters versus the smaller leaks. There's a 2016 study by Brandt at Stanford University that showed that about 70%, between 55 and 70% of the total volume emitted came from about 5% of those leaks. So that means, in other words, a small number of very large leaks can, when they're addressed, you're addressing a big chunk of the problem. So that's the role that satellites play. Satellites cannot obviously handle the smaller leaks. There are many, many, many more of those smaller leaks. But the idea is that in a tiered system where you deploy different technologies at different frequencies, for example, satellites on a weekly or almost daily basis, if possible, to find those big leaks and eliminate them. And then you can deploy other technologies like aircraft or drones, but then you can afford to do it perhaps a bit less frequently because you know that the big leaks have been captured. So you can use the budget more judiciously by deploying these other technologies, perhaps slightly less frequently, and then also have on-the-ground measurements, whether it's in situ monitoring or someone walking around with an optical gas imaging camera. And it's widely accepted now, and we're big believers in that at GHGSat, that there's no silver bullet to address this problem. It really is a combination of all of these great technologies in order to capture, identify, and address the whole spectrum of leaks. There are of different types, there are of different sizes, so they're not all born equal. And armed with all of these technologies, it becomes possible to really address the full spectrum and to do it at the lowest possible cost to the operator as well, so that they can have budget to actually fix them as well. So it's monitoring is just the first step.
Sure. So you mentioned that you're expanding your constellation of satellites. What else can we look forward to moving forward from GHGSat? How are you expanding, geographically?
Yes, so we already have offices in a few places around the world. So of course we have a presence in the U.S. because of the oil and gas industry in Texas there. So we have a presence there. We have several offices across Canada. So our aircraft operations are based out of Calgary. Our analytics center is based out of Ottawa, and of course we're headquartered in Montreal. But now, for the last several years, we've had an office in London in the UK, and we're constantly looking at the next possible place to expand to best serve our customers. So whether that's the Middle East, Southeast Asia, we want to be close to our customers in order to have the right conversations and showcase what we do properly, and that's usually done in person. So we continue to grow that way, and I think that's something to look forward to in the next year or two. Now, we've just recently announced that in the second batch of 3 satellites we're launching this year, there will be a CO2 satellite. So
Okay.
that's a little bit different. After the focus on methane, we're now turning our attention back to CO2 as well. Our first satellite or demonstrator was initially intended to do both. It was designed to look at CO2 and methane, but for many reasons, we decided to focus on methane first and be very good at it. One of the lessons learned was that we were better to focus on one gas at a time. So we did that with methane. The business case and the demand continue to be there for CO2. So now the time was right for us to turn our attention back to CO2 with a dedicated CO2 satellite, so that we can bring that data as well to our customers, so that they can best understand their entire greenhouse gas footprint.
And oil and gas, your main focus, but what about other sectors? What else are you branching out into?
Yeah, so like I mentioned, oil and gas is our primary sector, like where most of our customers are, and that's because, of course, methane is the main component of natural gas. So it is obviously a natural, a good fit. But there are other industrial sectors that are considerable emitters of methane. So we do a lot of work in waste management, so landfills and dumping sites around the world. So we image these types of facilities on a daily basis around the world. And also coal mining is an industrial sector where we see a lot of methane emissions, and that's from both open pit and underground coal mines. So, and finally, to a lesser degree, but we have several examples now in agriculture. So, for example, cattle feedlots, where you put thousands of heads of cattle in the same place and they're feeding, that can generate considerable amounts of methane. And we have examples where we've been able to see that from space. And also facilities like biodigesters, for example, if they're malfunctioning, if they have a leak, that can be quite significant too. So those are just some examples on the agricultural side, but those first three sectors I mentioned, oil and gas, waste, and coal, form the vast majority of the work that we do around the world right now.
Okay. Well, thank you very much for the conversation, Jean-Francois. Any finishing remarks?
Finishing remark here is that what I would say is something I've been mentioning a lot lately in a lot of discussions, because in these types of discussions and interviews, there's always an interest about knowing about what's next for the technology. What's the next big step in technology improvement. And I think it's clear now that technology is here to address emissions. So, and that's not just satellites. That's not just GHGSat. There are a lot of really great technologies, aircraft monitoring, drone monitoring, in situ, that have made great strides in the last 5 years, last 5 to 10 years. So the technology is here. We're identifying emissions on a daily basis. So the opportunities are there for impact, and it's time to now turn to action. So that's my parting thought here. In 2022, GHGSat identified 8 megatons of methane. So that's equivalent to over 45 million cars on the road for a full year. So, and out of this, only a small fraction was confirmed to be reduced, to be addressed. So opportunities are now here. They're clearly identified. They're pinpointed to specific facilities. And the data is timely. The data is provided in less than 24 hours. So the opportunities for reductions are here. So the time is now for action. So that's my parting thought, Joseph. That's my last message here, is that the work's been done. The data is here. The technologies will continue to improve. This is great, but the opportunities are here today.
It's a good closing thought. Okay, thank you very much. This has been another episode of In a Nutshell, Natural Gas World's podcast. Thank you for tuning in.